Hello everyone, welcome to the course of data science, a discipline to foresee the future. Wish you a very happy new year for the year 2020, and let's have a resolution to master this outstanding field, outstanding discipline of data science in this year. In this introductory brief video, I will try to motivate you enough so that you are able to pursue and you get motivated enough to pursue this particular course. We will discuss the course instructions, how we proceed the course in details in the next few slides. Let's see how it goes. Now, what is data science? Well, it stands with a business problem. It starts with a business problem. We need to understand what problem we are trying to solve and the business context around it. That's why the data science is a multidisciplinary subject because it involves business, it involves in many other quantitative subjects as well. That's how crucial the data scientist's job is. So let's say we understand the business problem. Now, what kind of business problem we are talking about here? Uh, for a bank, let's say there are many retail customers are applying for loan. Now, a manager, a bank manager, or a relationship manager doesn't have time to go through all the customers' profile, all those things, to manually go through all of them and to decide whom to give loan or whom to not. So let's build a model. Let's build something. Let's automate the task so that whenever a customer enters his profile, our our data science models will tell the relationship manager that look, this customer is not that good. You cannot disburse a loan to that customer of that amount. He's not going to pay. So he's not good. His profile doesn't look good. Also, it may say he's a very good customer. He has a very good credit score rating. He has a stable income. He is working in government. He has stable income. He wants to take loan the money for his, let's say, vehicle. Let's disburse the loan to him. So that kind of automatic stuff are done in data science. So see, that is, so starting with the business problem that should I provide the loan to that particular person or not? So starting with the business problem, we apply our data science techniques to arrive at the solution so that it improves organization's business. So how does it improve? So it improves time, and as you know, time is money. So that is how the entire chain of data science works, and we have to keep in mind that starting with this business problem and ending with the solution delivery, the entire end-to-end process is the responsibility of a data scientist. So business, the organization will tell us the problem only. So you have to figure out how to apply those techniques, how to apply the methodology so that you arrive at a robust level solution. That is what data science is. Now, how to use data science in practice? That is the big question. So, as we discussed in the earlier slides as well, that the first and the foremost thing for a data scientist to be is to be aware of the business problem that we are trying to solve, understanding the business context around it. So, what is the purpose of building that data science model? What is the purpose of it? What kind of problems we are trying to solve? So, once we understand the business problem that we are trying to solve, we then move into our next big chapter of data science, that is the data collection, analyzing the data, producing the solution, and then finally discussing the solution with the business manager who will take the decision whether he will apply the model you have built, whether the organization will apply the solution that you have built in production or not. So I'll briefly describe the middle section of this, that what is the responsibility of a data science. Now, you have understood the business problem. Now you know clearly that what we are trying to answer. Based on that question, you have to figure out what kind of data will support you, what kind of data you will require to answer that particular question. So that's the next big task: accumulate relevant data. So otherwise, nothing will make sense. So you have to accumulate relevant data, which are so relevant data means that the data set that will help you to answer that particular question which you are trying to solve. Then, after you have collected the data, you understand the business problem, all things are good. Now it comes to what kind of statistical, mathematical techniques that you will be using to analyze those data. Now that is a big part, and that is the part where you require skills, where you need to practice, where you need to have experience, where you need to have stat skill, where you need to have mathematics skill, where you need to have programming skills. So all these things are required in that part. How to use, what to use, when to use, what not to use, what techniques do you use? So all these questions are coming in this part. Use appropriate techniques. Now after you use appropriate, let's say you have figured out what kind of technique you will be using, and you have chosen after discussing with your colleagues, let's say, who are also by the way data scientists. So your team, you come up with a solution that this is the technique that we will be using. Now deliver robust and reliable solution. So what does it mean? So robust and reliable solution means, so to answer the business problem, you have accumulated a particular data set. But if the scenario changes, how will that affect your data science models that you have just built? If that scenario changes, how robust is your model with respect to the scenarios, with respect to times, let's say? So how reliable your solution? So you have built a, so let's say you have built a model in 2020 January. So will that model be relevant, or will that model be relevant in 2021 or 2022 or 23? If not relevant, what kind of changes the model needs? So you need to figure out all these things. That these are the model limitations. These are the model's drawbacks. If that changes, I need to fix the model again. I need to fix that, fix these. So these kind of things you need to be aware of, because you are the one who has built the model. So, okay, so enough of this. So let's say we have successfully completed the middle part, that is the core responsibility of our job profile, that delivering of robust and reliable solution. Now, in the middle part where we have these three steps, throughout the steps you have to maintain one particular, you have to keep in mind one particular point, that is maintain time and cost efficiency. If any of the steps require more time than it worth it, then the project will be discarded. Then it's not worth doing. So let's say you are trying to answer a question, and to accumulate data to answer that question requires a huge amount of cost, huge amount of time. So business will not approve for that particular project. So for each of the steps, you need to be aware of what time and cost effectiveness are going to be there to build your project. So you need to keep that in mind, that in every step of what you are doing, time and cost effectiveness has to be there. Now, let's say keeping all those things in mind, you have come up and you have ended up with a very reliable and robust solution of a data science model. Now, what will be your next step? As a data scientist, what will be your next step? So, your next step will be again to go back to the business, because at the end of the day you are trying to improve your organization's business by reducing the cost, by reducing the manual effort, by reducing the human error. So you have to go back to the business to discuss what, to discuss that look, this is the problem that we had, this is the solution that we have built, and this is how this will improve our organization's business. Now the business leaders who will be taking the decision, the big senior leadership may or may not agree with you, but it's your responsibility, it's your sole responsibility to convey the solutions that you have built to them so that they take the decisions to deploy your model in production. In production means use the model in real life scenario, in live scenario, and, that is how they uh, come up with that is how they reduce cost and improve efficiency. Let's say. And that's where your job stops, not earlier than that. So keep that in mind. Well, in earlier slide, we have seen how to use data science, and now in this slide, we will be discussing why do we use data science. That means actually, why does a company, why does an organization or government need data scientist to be in his to be as its employer? So why does it need it? So organizations, companies need data scientists because data science is a discipline which help us to understand the data, the story behind the data, the inherent story behind the data. That behind story we cannot see in naked eye. That story can be found if we apply data science on voluminous heterogeneous data. So that is the main purpose of doing data science, to gain insight from the data. And why is it important to the business leaders, to the senior management? Because based on those insights, they will strategize, they will take business decisions. So let's say in a particular country, the economic situation is very worse to that particular country. Now, do you want to disburse a loan to that country? Do you want to invest your hard-earned money to that country? Now, this is a big business decision, right? Now, similar kind of business decisions in similar kind of business decisions are taken based on data science insights. That is how crucial a data scientist's job is. So you have to keep those things in mind. Anyway, let's keep it short. So I have put here four brief points. So why do we use data science? Now, of course, process voluminous and heterogeneous data to gain insights. So that's pretty obvious, because we humans cannot just read through that data. That's insanity. So data science models help us to get the insights from the data after processing, after summarizing. So that's all. Capture non-linear complex relationship. So let me explain what that is. So everything is not linear. So linear means if that increases, that one decreases, or if this increases, that one increases also. So everything is not that linear. So it's not that easy to find what kind of relationship two variables has among them. So those complex non-linear relationships, so data science models, data science techniques are able to capture those relationships, which wouldn't have been possible if there hadn't been any data science techniques. Computationally efficient. Of course, there are millions of data. We have to process those. We have to summarize those. We have to tabulate those. So, I mean, computationally efficient, of course. Automation, and this is the part actually that gets less emphasized, but I want to emphasize it very much, that automation is one of the important tasks that a data scientist have to keep in his mind, because what does automation do? Automation removes human error. Automation minimizes the cost. Automation minimizes the time to do something. So you have to keep those things in mind, that automating is a significant part of your project or data science project. You have to keep those things in mind. Now, of course, data science is a combination of machine learning, statistics, models, data analysis, and all those things come in data science. So maybe, I mean, it's as I said, it's a multidisciplinary field. So you need everything, almost everything for that. So but it's not. But it's doable. So it sounds so many things, but it's doable because that's how we are doing it. So there are ways to do that, and that is what you will be learning in the courses, that how to do those things, how to get required skill, how to get how to enhance your skill on these things. That is what you will be learning in the courses, in the course in details. Yeah. Now, this is the part where we discuss when do we use data science. Well, when and where do we use data science? It will not be exaggeration if I tell you that in almost every sectors, in almost every companies, there is this place, there is a scope to use data science. So it will not be a word exaggeration. So you have to keep that in mind. So for example, fraud and risk detection, those are used in finance or any industries, healthcare analytics, website recommendations. You get recommendation on Netflix. So how does Netflix know that you like let's say animation movies? So how does he know that? So the recommendation system customizes the recommendation for you only. So how does he know that? So it's a very challenging task. So that is where the data science is being applied. Banking, retail industry. So banking industry, whether to give a loan or not. So if a customer defaults, how much will the bank lose? So those kind of stuff. So in almost every field, data science is used. Now, to dig deep into the sections where when to use what techniques, if I phrase this question like this. For example, we have our classification problem. So, as I described earlier, is the customer good or bad? It's a classification problem. We have our regression problem. So, let's say recruiting company. A recruiting company wants to know that if I recruit or if I get employees from that particular sector, how much salary that particular person will ask me. So so how does salary vary based on industry, based on experience, based on age, based on sex, and all those things? So that's a regression problem. That's a typical regression problem. It is actually more complex than that, but I'm just simplifying it. Design of experiment. So it's design of experiment is a big statistical part which is used in healthcare industry. So is the drug working or not? So how do you prove that the drug is working? So drug is being used on human body. So you cannot just expose a toxic drug to human. So that will not be done. Your company will be shut down. So how do you know that the drug will be working? Because or maybe there is already an existing drug. How do you know your drug is better than that existing drug? So how do you know that? So do you have enough evidence to prove that your drug is actually working and it's actually better than the already existing one? So how do you do that? So that is why the design of experiment comes in, and that is the part of data science. Time series data. So what is the periodic component in my expenditure? So how my expenditure curve, how my expenditure time series curve vary, how based on seasonality, based on cyclicality. So what is the periodic component, and based on that, can I predict what kind of expenditure I'm gonna have in the next 6 months, next 12 months, next 2 years? So can I predict that? So these are kind of problems. When you face these kind of problems, that those are the times when you call a data scientist. When you call a data scientist and look, solve these problems for me, I'll pay you. So that is when you use data science. Okay, so it's time for an example. So it's not an example actually, it's a real world case study. And this particular example I picked because uh, I have worked in these kind of studies, in these kind of problems. I have solved these kind of problems. So we'll be starting step by step. We'll be doing step by step description, but I'll try not to dig into much deeper details, but the overview will be sufficient to be understood. So, uh, So a healthcare company tries to publish his drug to market, right? Now let's say they have synthesized a particular drug for fever, let's say for a viral fever. Now, based on the class of drug, there is a common tendency. There is a tendency that when you take drug, uh, that drug will do some reactions on your body, and there are some drugs which will do certain reactions that will cause elevation of your heart rate. So you are getting or you are taking a medicine for a viral fever. Now, what is as a side effect, what is happening? The heart rate of yours is being elevated. Now, one problem of elevated heart rate is that if it's beyond the cutoff, if it's beyond a certain cutoff, you will face a heart attack. But you just take you just took an medicine for viral fever, but you don't want to have a heart attack, right? So, but certain drugs have this tendency to cause elevated heart rate, to cause an elevation in heart rate. So the drug, let's say in US it's FDA, the Food and Drug Administration will not allow those kind of drugs. The drug may be very good and very efficient in curing the viral fever, but if it causes heart attack, it's not worth it, right? So when the drug company applies for publishing the drug to FDA, it has to prove that, look, my drug is actually curing the viral fever, of course, but it's not causing heart attack, it's not causing elevation of heart rate. That is what you have to prove. Now, how do you prove that? So you have to prove based on data, right? Otherwise, how do you know that? Now, this is a kind of typical example you can get from this kind of clinical trial, that you have patients, and one particular row corresponds to one particular patient, where you have patient's age, sex, and drug dose, and all these things. What kind of area he is from, and what kind of disease history he has, what kind of disease he has right now. These kind of information are available, let's say, in a clinical trial. Now, based on those, you have to figure out whether your drug is causing the elevation in heart rate or not. And there is a industry standard cutoff, industry standard cutoff, in the sense, in FDA standard cutoff, that if your drug actually causing heart rates, or here in this case called this QT interval, it's an interval. This is the ECG graph. It's an QT interval. If this interval gets bigger than a particular cutoff, then your drug will not be approved. So it's as simple as that. So basically, we have to prove that, look, our drug is working, and our drug is not having that our drug is not going beyond that cutoff, right? Now, to be precise, so what is the variable that we are trying to measure? We are trying to measure this QT interval. So this is the response variable that we are trying to measure. Now, this is an ECG graph rate. Okay, now this interval, so every time your heart beats from this to this kind of graph you will see on the ECG screen. Now this interval is called QT interval. So just for the timing, ignore the medical facts. Just let's understand that if the QT interval gets bigger than a certain cutoff, then our drug will not be approved. Now, in a clinical trial, and this particular study is being done to replace or to get waiver of a thorough QT study. So to prove this particular fact that our drug is working and drug is not causing elevation in heart rate, you actually have to do a thorough QT study, and that costs much more. So what company does, what healthcare industry, healthcare companies do is, they, with the help of data science, they prove that we do not need to do an entire separate project to prove this particular fact that our drug is not causing elevation in heart rate, we can do from the existing data of our clinical trial. What kind of data we have already in our clinical trial? That this is the drug dose, 100 mg, 400 mg, 500 mg, 600 mg, like this. This is the drug concentration. So how does it measure? It's basically mg per ml. So the concentration of the drug in your blood. Now, so if you take higher dose, you will have higher concentration. So stuff like that. Now, this is the kind of analysis that healthcare company performs, and data scientists they perform to prove that their drug is actually safe, or their drug will not be causing heart attack to those patients. Now I have just plotted these graphs. This horizontal axis is concentration, and this vertical axis is this difference in QT interval. Basically, difference before the drug, and after the drug QT interval. If that difference is bigger, that means your drug is causing to have that bigger difference, so you will not be approved. So stuff like that. So I'll not be going into the deeper analysis on what kind of models we have used. So it's basically mixed effect model we generally use for this kind of analysis. MMRM, it's called MMRM, but will not be, so those will come in the courses in details. But yeah, so this is the end result of the analysis will be like this, and you have to write a big report to prove this and that, and the entire conclusion, the ultimate conclusion will be that look, even though we in a higher concentration, higher dose, my QT interval, the difference in QT interval is not going to be beyond that cutoff, so you can approve my drug. So that will be it. That's all. So that's a nice example of real world case study of data science. Well, we are at the end of this introductory video. I have set up 3 quick questions for you. Well, the first one is, it said in the data science that the domain knowledge is required very much. So I have answered these questions in the video itself. So maybe you can go back and get the answer from there as well. What would be the practical problem if you want to data science with pen, pencil, and a calculator? That's an interesting one. If the solution provided by you is not robust, then what kind of problems you might face? These are solutions for all these 3 quizzes you can find in the video itself. Now I have an exercise for you as well. The exercise is that what would you do if collection of data and processing of the data in real time take a very long time than your organization is willing to pay? Then what would you do? But as a data scientist, you are sure that if you build the model, it will work smoothly and help the organization's business. Now, when building the model, or before even starting the project, you have to convince your senior stakeholders that this is the solution I have thought of. If you approve me, I'll go ahead with the solution, and this will help my business. Now, how do you prove the cost effectiveness? How will you convey your stakeholders, even though you know that the processing the data and collection of the data will take a very long time? So how do you proceed with that? So I haven't answered this question in the video, so you have to think of the answer on your own. I can give you a quick hint. So the hint is that cost effectiveness and efficiency might not be instantaneous. So think the solution in a long run. So would that help? So okay, that's it. See you in the detailed course again. Thank you for watching the introductory video. Talk to you soon.